Hey guys, my name's Amir, and today we're going to be doing a more complex force mathematical problem. The question today is about forces on an inclined plane. So let's get into it. So here's a little bit more of a complicated question that involves math calculations. A 40 kilogram child sits at the top of a 2.6 meter high slide that is inclined at an angle of 30 degrees to the horizontal, as shown in this diagram. If a frictional force of 28 newtons acts on the child as she comes down the slide, what will her speed be at the bottom? So the first step is to draw a diagram of the situation. So we want to draw a force diagram and keep it simple. So we're just going to represent the girl as a block because blocks are nice and easy. And now we want to label the forces acting on the girl. So we're going to have a weight force, and that's equal to mg. We're going to have a normal force that's holding the girl up. We have 2.6 meters in height, and we have a 30-degree angle. And we have frictional force of 26 newtons going in the opposite direction of motion. So to work out her speed at the bottom of the slide, we're going to need to know her acceleration. So to work out the acceleration, we're going to need to work out the net force. The net force means the sum of all the forces all together. And now in this diagram, we're actually going to split it up into two. We're going to split it up into motion perpendicular to the plane and motion parallel to the plane. So this is parallel to the inclined plane or to the slide, and this is perpendicular to the slide. So the sum of the forces is going to be the sum of the forces perpendicular plus the sum of the forces parallel. Now, here's the tricky part. We're actually going to have to do some trigonometry. So what we want to do is we want to split up this mg, the weight force, into its perpendicular and parallel components. So we do that with trigonometry. So we want to split it up into a perpendicular component and a parallel component. So that way we can use it when we're doing our sum of the forces. Now the tricky part is trying to figure out where the 30 degrees goes in this triangle that we just made. So if you do some basic trigonometry with parallel lines, you can draw some parallel lines here and do some parallel lines there. You can actually see that the 30 degrees will go there, right? If I drew the triangle a little bit differently, if I drew the triangle here instead, then the 30 degrees would go there. So let me show you. If we drew the triangle like this instead, then the 30 degrees would go there. So one thing I'd recommend you do if you're ever doing an inclined plane question is you want to draw the triangle in a consistent format every time. So the way I do it to make sure it's consistent is I will always draw my perpendicular component along the same line as the normal force. So my downward line won't be on this side, but instead it will be joining and connecting straight from the normal line. So like this. And that way you can actually just kind of memorize that if you draw it like this, the 30 degrees will always be in the top corner. Because if you drew it the other way, then the 30 degrees ends up in the bottom corner. But if you draw it this way, the 30 degrees ends up always in the top corner, and you don't have to do some little bit of complicated trigonometry to kind of work that out. Then there's another rule that I like to memorize as well, is if your component, so we're trying to work out this parallel component, for example, is opposite to the 30 degrees, then the value for this will be mg sine 30. So if it's opposite, we use sine for the value for this. And since this is adjacent, this side here is adjacent to the 30 degrees, we're going to call this mg cos 30 degrees, right? Adjacent and opposite, like how we know our trigonometric values. All right, so now that we've worked that out, remember this is going down and this is going to the right, then we can actually solve our problem. So we want to know the speed at the bottom of the slide. We only care about the parallel force. If you actually look at the perpendicular forces, they will cancel each other out. So this is one technique of being able to work out what the normal force is. Even though it's unrelated to the question, the girl is not going to be falling into the slide, or it's not going to be accelerating downwards, and the girl is not going to be suddenly floating into the sky. So that means we know that the normal force needs to balance out the weight force. So I'm just writing in this here so that you guys have an idea, but that's actually not related to the question that we're trying to do. But some questions will ask you what the normal force is, and that's how you work it out. So the question that we have is how to work out the velocity, and we're actually going to need the acceleration. And to work out the acceleration, we're going to need the net force parallel to the plane, because the net force perpendicular to the plane is actually 0. So this is actually equal to 0 plus the sum of the forces parallel to the plane. So why is it 0 again? Remember, the normal force cancels out the weight force that's on the same plane as the normal force, because the girl isn't going to fall into the slide and the girl is not going to start floating into the sky either. We actually are going to need to define a direction to be positive. So we're actually going to define the downward direction to be positive. So just keep in mind, going down means positive. Then that means what we actually have is we have an mg sine 30 going down the slide, and we have a 26 newtons going back up the slide. So the net force parallel is going to be mg sine 30, and that's positive because that's going down, minus 26 newtons. So we can now plug in our numbers. We have our mass as 40 kilograms, our g is 9.8, sine 30 is a half, and subtract 26, and that will give us 170 newtons downwards. Okay, so what's the point of this? The point of this is now we can use Newton's second law, F equals to ma, to work out the acceleration, and with the acceleration we can then work out the velocity. So we want to make acceleration the subject. Acceleration is going to be the net force divided by the mass, which is 170 divided by 40, which gives us 4.25 meters per second squared. Alright, so now that we have the acceleration, we can work out velocity and distance and various other things using our kinematics formula. So we'll put up the kinematics formulas over here. Now, when we're trying to work out the velocity in this case, there's one thing you want to see, and you want to see that in the question, we're not actually given the time taken. So because we're not given the time taken, there's only one formula that doesn't have a time in there, and that formula is v squared equals u squared plus 2a delta x, where delta x is the distance that you've covered, acceleration is the acceleration that you have, and velocity, v stands for the final velocity and u stands for the initial velocity. So we actually haven't finished the problem, and we actually need to work out the length of the slide itself so that we can sub that in for delta x. So if we can use our trigonometry again, we can work out what the length of the slide is. We can see sine 30 is equal to 2.6 meters divided by the length of the slide, so let's call that delta x. Therefore, delta x is going to be equal to 5.2 meters. Alright, once we've done that, we now have the delta x, we have our acceleration, and we're trying to find the final velocity, and we know what our initial velocity is. The girl is just sitting at the top of the slide, so initial velocity is 0. We can now work this out. Velocity is going to, v squared is going to be equal to 2 times 4.25 times 5.2. So v is going to be the square root of all of that, which gives us 6.65 meters per second. And that's it. And that's how we solve this question. So I hope you enjoyed that video. Tag a friend that needs help with forces and they don't get it, because it is pretty confusing. And if you have any future questions, just let me know and we'll figure them out for you. Thanks.